Okay, Assalamualaikum and good afternoon. Can you hear me?
Can, Doctor.
Yes, madam.
Okay, so we have 39 students today. Actually, I expect more because I did combine this section with my another section. We schedule on 4 p.m. But it's okay. Okay, so today is the last class for this semester. Okay, so we should finish all the syllabus by today lah. Okay, and we have about three more subtopic to cover today. Okay, but we go through by the exercise question lah. Okay, by the exercise question. Okay, so by using the exercise question, we discuss lah. Okay, the subtopic. But actually, this chapter 6. Even though we have 4 different hypothesis testing, but it is actually two method. I mean, two similar method. Okay, so you have 6.1 for the goodness of fit, and you have 6.2 for the contingency table. Okay, so under goodness of fit, you have two different hypotheses. Not two different hypotheses, similar hypotheses, but different nature. Okay, different nature. Okay, nature of your data. Okay, and different distribution that we try to fix the data. Okay, and you have the contingency table. So contingency table, it is between two categorical data, okay, or two categorical variables. Okay, so contingency table, you will have the row variables and also the column variables. Okay, so we have two hypotheses involved for the contingency table. So you have the independent test and also you have the homogeneity test. Okay, so as I mentioned last week, the chapter 6 here, it is about categorical data, the qualitative data. So the data that you have is a frequency data. Okay. Okay, so that's why for the contingency table, the homogeneity, it is about the proportion because of categorical data. Okay, so I do hope that you already watched the video from previous class. Okay, the video that I shared to you. Okay, so it should be, we start with the exercise 6.1.1 today. Okay, so the number 2 question here. Okay, I do hope that you already do the exercise. Okay, so today just to discuss lah. Okay, so the number 2 here, the following percentage of the Malaysia retail car sale based on the brand. Okay, okay, and the question is at 2.5% significant level. Is there any sufficient evidence to conclude that the claim of the recent study can be accepted? Okay, so what is the claim? So recent study, so refer back to the recent study here. Okay, so automatically the recent study here, that's your HNA. Okay, because HNA always it is about the claim of your data. Okay, so the claim here or the recent study here, okay, you are given percentage. So percentage here, it is distribution or not distribution, distribution of your data. Okay, so by using this distribution, we calculate the expected frequency. Okay, expected frequency, the expected frequency data lah. Okay, so you need to watch the video that I shared to you last week because I already discussed in that video the introduction to this chapter. Okay, so goodness of faith, it is about we try to determine or we try to compare the performance of the actual data with the expected data. Okay, so you have the expected frequency, you have the observed frequency. So observed frequency is actual data. Okay, so the data given in your question, okay, like this exercise, we have a survey in Kuala Lumpur indicate that 100 cars sold. So we have 25 product you have 50 Toyota and 10 Mazda and also 15 Honda. Okay, so this is the actual data which is observed frequency. Okay, so distribution here, Bayesian distribution. So in this case, you have percentage as your distribution. Okay, so Bayesian this distribution, we calculate the expected data. Okay, the expected data, and then we compare the expected with the actual data. Okay, if letter your chi-square test is smaller. Smaller means that when we do the decision, it is do not reject hash null. Okay, so when you have do not reject hash null, means that chi-square is smaller, means that observed frequency, your actual data close to the expected frequency. So we have a good fit data. Okay, that's what we meant by goodness of fit task. Okay, if in your decision letter it is reject hash null. So reject hash null means that actual performance far from the expected performance. Okay, so you do not have a good fit data. Okay, so why we try to compare here, because of course we need the actual data to be same as a expected data. Okay, then you will have a good data lah. Okay, then you will have a good data. So this is how, this is one of the method that we can use to check that. Okay. So we go to the what we call the answer lah. Okay, you can interrupt me anytime if you have any question. Okay, so I already have the answer here. Let's discuss. Should be here. Okay. Okay. So as I mentioned last week, okay, the whole chapter 6 here, it is about chi-square distribution. Okay, it is about chi-square distribution. Okay, so you will calculate the chi-square test as your what we call test statistic. Okay, and the whole chapter here, the similarity, it is on your the type of the statistical hypothesis. Okay, I mean how you do the decision. So decision is based on the right tape test only. Okay, so it is right tape test only. So it is related also to the chi-square must be positive. So right tape test only for the whole chapter 6. Okay. So because of the hypothesis, so you still have those 5 steps. Okay. So the step 1 is to state the hypothesis. Okay. So step 1, hypothesis. So you have hash null and hash 1. Okay. So hash null is here. Okay. You can see, right? Okay. So for the goodness of fit task, hash null always be the claim. Okay, so claim of your question we state at the hash null, or it is a distribution of your question. Okay, so for the categorical data 6.1.1.1, okay, distribution means that sometimes means that you will have percentage, or you have the ratio, or you have I mean there's no percentage and ratio, then we have the category, the number of the categorical data as our distribution. Okay, but for the 6.1.2, you will have Poisson, normal, and binomial. Okay, so other than we state the claim at your hypothesis, you can state the distribution of your hypothesis. Okay, so what you have here, the hash null here, Okay, this is the distribution because we have percentage of retail car here. Okay, so you just write back what is your distribution. Okay, that's your H0 and H1 opposite to that. Okay, so the percentage of Malaysian based on the brand are not same as stated in the null hypothesis. So opposite to that. Or you can state that based on your question. Okay, based on your question, it is a claim that recent study is accepted or not. Okay, so you can write here for your hypothesis. Let me check again the question. Yeah, betul. Okay, so kalau you tulis macam ni pun accepted lah. Okay, because we follow the question. Because the question state that the claim that the recent study can be accepted. Okay, so that's your claim. Recent study is accepted. Okay, so you can write like that lah for your hypothesis. Okay, so H1 opposite to that. It's up to you how you are going to write, but as long as it is opposite to the H0. Okay, or you can state the distribution of your data. Okay, so distribution here is a percentage of your categorical data lah. Okay, percentage of your categorical data because here you have the percentage as your distribution. Okay, if you have ratio, then you can state the ratio. If you have number of the category, then you can state the number of the category. Okay, so we just follow the question. Okay. And then the second step is to calculate the chi-square test here. Okay, but before we calculate the chi-square test, we need to calculate the expected frequency. Okay, so the expected frequency, the REI. Okay, what's given in your question is an observed frequency. Okay, observed frequency. Okay, you have to know how to distinguish lah. Okay, the information given, it is a distribution or it is a frequency. Okay, frequency must be a whole number lah, discrete number. So you have observed frequency given in your question. Okay, so if we sketch this table, then the first row is your observed frequency and the second row is the expected frequency. Okay, in order to calculate the expected frequency, it is the formula that we use is a NPI. Okay, NPI. So N here is a total sample or total data. It is not the NI. Okay, some students they read as a NI. Okay, what is NI? They use this number. Okay, it is incorrect lah because this is not the N. This is the observed frequency. So the N here, okay, if given in the question, then you can use as it is. If not, you can calculate the N. So N is a summation of OI. Okay, summation of OI. So you can calculate from the data given. Okay. So PI here is a probability, which is based on distribution. Okay, based on the distribution. So distribution, okay, for the categorical data, you will have three types of distribution. I repeat, first, either you have the percentage, second, either you have the ratio, and third, there is no percentage, there is no ratio, then we use number of category to find your probability. Okay, for example, that there is no percentage, there is no what we call ratio. So we use number of category. So number of category, we have Produa, we have Toyota, Mazda and Honda. Altogether K equal to 4. So K is a number of category. So your probability here for the Produa, the first category, it is, apa dia? Anyone? If we use number of category as our distribution here, so probability for the Produa, it is 28 over 100, it is based on the percentage. Okay, but here let's say that there is no percentage given. We use number of categories, so it is 1 over 4 lah. 1 over 4. Sorry, 1 over 4 for the Produa. For the Toyota, similar 1 over 4. For the Mazda, also 1 over 4. For the Honda, also 1 over 4. Okay, but that's by using category. Okay, so in the case of you don't have the percentage or ratio lah, okay, then we use number of category. Okay, but here we have the percentage as our distribution, so we use 28 divided by 100 lah, as what your friend said, because percentage the total is 100, so divide by 100 you will get 0.28. So that's your probability for the Produa. Okay, so this one. Okay, no, yeah. This one. We cannot use as it is because PI is a probability. Okay, so we have discussed somewhere when we discussed the proportion in chapter 3. Okay, probability means that the value from 0 to 1 only. Okay, cannot be more than 1, cannot be less than 0. That's probability. Okay, if more than 1, it is not probability. You might have the frequency. Okay, so that's your PI. This is PI lah. And then multiply with the 100, and coincidentally, your N is a 100 here. Okay, that's why you get back the percentage here. Okay, coincidentally, the N here is a 100. So you get back the percentage. Okay. So that's your expected frequency. Any question for the expected frequency? How to find the expected frequency? Any question? Okay. Okay, so then we have the expected frequency. Before we calculate the chi-square, what we need to do? We have the expected frequency, but before we go to calculating the chi-square, what we need to do? Anyone? Okay. We check the assumption. Okay, we check the assumption of the expected frequency. Okay, so in theory, the expected frequency, the E here, must be at least 5. Okay, must be at least 5. Okay, then after you ensure that all the E greater than 5, then you can proceed to the chi-square. Siti Noratika, you try to say something? I cannot hear you.
Sir, madam, to tekan.
Okay. Okay, so we need to check the assumption of the E. E must be at least 5, okay? But in this case, all the E greater than 5. Then you can proceed with the chi-square. So what happens if the E less than 5? Okay. If E less than 5, then we need to combine the category. So how do we combine? For example, okay, for example that we have, okay, so Pro 2, Toyota, Mazda, Honda. Okay. Okay. This is your OI, this is your EI. Okay. Okay. 25, 50, 10, 50. Okay, let's say that the first category less than 5. Let's say that we have 4. So what we need to do here, we combine with the next category. Okay, so the first category here, E less than 4. So we need to combine the category. So which category that we need to combine with? It is category after that. So we combine P with the T. All must be combined. So instead of K equal to 4, you will down to the K equal to 3. Okay, so you will have P plus T, you will have M, you will have H. OI, EI. So for the first category here, it is a new O, new E. Okay, O 25 plus 50, so you have 75, and then here you have 51. Okay, and M and H similar. Okay, let's say that, so the rule is we combine with the next category. Okay, but if the last category here less than 5, so what we do, we combine with the category before that. So plus, plus, plus. Okay, so instead of K equal to 4, okay, let's say that here we also combine, and here we also combine, you will down to the K equal to 2 here. Okay, so the next step, chi-square. So if you combine the category, the next step must be based on new data. Okay, the new data, which is this one. You cannot use the old category, the old data here. Okay, the next step, we have to use the new data. Okay, so instead of K equal to 4, it will be K equal to 2. Okay. After you ensure that all the E greater than 5, then we can proceed with the chi-square test. Okay. You need to combine the category until all the E greater than 5. So let's say that we have, here is 2, here is 1. Okay, so 2 plus 1 still less than 5. So add with another category, this one. So you will combine P, T plus M. So 3 category here become 1 category, because we need to make sure all the E here greater and equal to 5. Okay, that's the assumption for the goodness of fit task. So it is for the 6.1.1 and also 6.1.2. For the fitting of the distribution also, E must be greater than 5. It is not the O. O, it is okay to have less than 5. Okay, don't get confused. O, it is okay to have less than 5, but E must be greater and equal to 5. Okay. So after you ensure that all the E greater than 5, then we proceed with the chi-square test. Okay. So by formula, you will have the chi-square here. Okay. Okay. So chi-square test here, it is the OI minus EI square divided by EI. Okay. So So you have the table here. Okay, since all the E greater than 5, then we use the whole data lah. Okay, we no need to combine the category. Okay. Hmm. So first category, it is a 25 minus 28 square divided by 28 until the last category. 15, 17. Okay, so then you will have your chi-square test. Okay, and the chi-square test here cannot be negative value lah, because chi-square is a positive distribution. Okay. Okay, so you should have 1.2482 for the answer. Okay, you should have that lah. Okay. And then the third step is your critical value. So we know that it is a right task. Okay, so it is a right task. So you will have chi-square alpha and then k minus 1. So k here number of category. So let's say that you combine the category. So the k here is a new k. Okay, do not use the old k. So we use the new k if you did combine your category. Okay. So after that, step 4, it is a decision as usual. So we make our decision based on right data. Okay. So in this case, your chi-square less than critical value. So it is somewhere here. Okay. Somewhere here, then do not reject hash null, the decision. Okay. So please do not write accept hash null. Okay. Please do not write accept hash null. It is wrong, accept hash null. Okay, it is do not reject hash null. Okay, so step 5 is a conclusion. So conclusion, you can write back your hypothesis, just a simple conclusion. You just write which hypothesis that you accept. So in this case, we accept the hash null because do not reject hash null, we accept the hash null. So you just write back your hash null. Okay, it will be accepted lah. No need to write. You don't have to write sufficient evidence and so on. You can straight away write which hypothesis that you support with the alpha. Okay, don't forget the alpha. Any questions so far? Okay.
No, madam.
Okay. So we go to the fitting of the distribution. Okay. So fitting of the distribution, we have 3 common distribution. Okay, that we task here. The first one is a binomial, then we have Poisson, then we have normal distribution. Okay. So binomial and Poisson, they are discrete distribution, and normal distribution, they are continuous distribution. Okay. So binomial distribution, we have 2 parameters. Okay. So binomial distribution here, we have 2 parameters. So your data distributed as a binomial with the n and p. Okay. So parameter, the number of parameter, it is important here when we find the critical value. Okay, because your critical value, we need to know, okay, the value of the, I mean, you need to know the number of your parameter. Okay. So it is NP. So N is not the sample size here. It is a number of success for the binomial, and P is a probability of success. Okay. And then Poisson here, we have your data distributed as a Poisson with the lambda. Okay. So lambda here is a average or mean. Okay. And the normal here, it is your data distributed as a normal with the mu and sigma square. So we have 2 parameters for the normal distribution, which is mu and also sigma square. Okay. So this subtopic, I think it is easier from previously. I mean from the previous semester, because this we already decide that we give you the probability value. Okay, the one that I share in column lah, the probability value for the exercise. Before this, we ask students to calculate the probability. So if you have this question in final letter, the crucial part will be probability. Okay, how to find the probability. Categorical data just now, it is very simple lah, because it just percentage or ratio or number of category. But for this subtopic, okay, how you find the probability, which formula that you need to use, it is depends on what distribution that you have, binomial, Poisson or normal. But okay, we already decide that it is not for the engineering students, so we already provide you with the probability. So you have to calculate the expected frequency. Okay, you just you just means that to calculate the chi-square, the first step is to calculate the expected frequency lah with the given probability. No need to find what is your probability. Okay, so before this, I'm quite what we call I'm quite worried lah if this question in final, but now it doesn't matter which question will be in final because we have similar start and it is easy lah. Okay, I mean for the fitting of distribution, there's no crucial part anymore. Okay, because distribution, the probability already given. Okay, so there's no excuse that you cannot answer that kind of question. Okay. So the H0 and H1, if you have the fitting of the distribution, H0, it will be always your data follow that distribution. Okay, so it will be either binomial or Poisson or normal, which is will be given in your question. Okay, it will be mentioned in your question. Test the hypothesis that the data follow Poisson, for example. Test the hypothesis that the data follow normal or the data follow Poisson distribution. We do not decide by our own which distribution that we need to fit the data. Okay, it will be given in your question. So you just follow the question lah. So H0 always be data follow that distribution. Okay, H1 contradict to that. The data does not follow the given distribution. Okay, just a simple hypothesis here. Okay. Basically, you have similar step as the categorical data, similar procedure. Okay, you have to state the hypothesis, compute the test statistic, how to calculate the chi-square also similar. Okay, what you need to do, check the E also similar. Okay, so E here also must be greater and equal to 5. Okay, so similar assumption as a categorical data lah, because both are about the goodness of it task. Okay, so similar step that we have discussed just now. Okay, for the critical value, okay, so the difference will be on the critical value here. So we still have the right tail tabs. Okay. Okay, so K here still number of category. So if you combine your category, make sure that you use a new K. Okay, make sure that you use a new K if you did combine your category. M. M here is a parameter. Number of parameter that estimated using sample data. So what does it mean? Okay, we know that, okay, binomial we have 2 parameters. Okay, if you cannot find any n, and here remember it's not sample size, it's a number of success. Okay, you cannot find any number of success in your question, and also you cannot find the probability of success, then means that in theory we have to estimate these 2 values. Okay, we need to find or we need to calculate these 2 values. if not in our question. So means that that what we meant by estimate using sample size. So means that we need to calculate these two value in theory. So your M just now equal to 2. Okay. But don't worry, we don't discuss, we will not discuss how to calculate those value because you will not use that value anywhere. Okay. We don't need that value actually in our calculation. Okay. But we need to know for our critical value. Okay. Why we don't need these two value for the calculation? Because probability already given. Okay. Before this, okay, we need these two value for the probability when we calculate the probability for the E. Okay, but now we already given you the probability in the question, then no need to worry, okay, about these two value. But we need to know whether these two value in your question or not, because it is for the critical value. Okay, if you cannot find your N and P in your question, means that in theory we need to calculate, so your M equal to 2. Okay, let's say that you have either one. Let's say that there is no N but you have P in that question. So in theory we have to find the P. So M here equal to 1. Okay, if either one exists in question. Okay, M equal to 2 if none exists in question. Okay, let's say that we have both in the question. For example, that thus the hypothesis that the data follow binomial distribution with parameters n equal to what? P equal to something. So means that you have both parameters. So in theory, there is no parameters that we need to calculate. So M equal to 0 for your critical value. Okay, so similar if you have the normal. Because normal also two parameters, which is mu and sigma square. Okay, so if you cannot find both, then M equal to 2. Either one given, M equal to 1. Or both given, M equal to 0. Okay. For the Poisson, lambda is a mean or average. Okay. If average given in your question, means that no need to find the average. So, what is your M?
0.
0. M equal to 0. Okay. If there is no lambda given, then M equal to 1. Okay. But doesn't what I need to say but the parameter is not really, not really important lah, because we don't use that parameter in our calculation, but we need to know for our critical value. So here we don't discuss lah how to get the N, how to get the P, okay, how to get the lambda, how to get the mu and sigma square. Okay, but we need to know whether they are given or not for the purpose of critical value. Okay, that's it. Okay. And then conclusion, you can you just write back your hypothesis lah. Okay, let's say that do not reject Hashna means that, let's say at alpha 0.05, the data follow Poisson distribution, for example. Okay, if reject Hashna means that the data do not follow the given distribution. That's it. Okay, just a simple conclusion. Okay. So actually I forget to inform you lah which exercise that you need to do. Okay, but that's okay. We go to the exercise. The example you can go through by your own. Okay, exercise 6.1.2 I think already discussed in the video. So we go to the 6.1 and 0.2 here. Okay. So test at 2.5% significant level whether this data fit to the binomial distribution or not with parameter. So this is your parameters. So automatically your M letter equal to 0. Okay. So So it is binomial distribution. So as I said, distribution given in your question, we don't we don't assume by our own what distribution that we need to fit the data to. Okay. Okay. So the what we call the procedure similar as the categorical data. Okay. 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 Okay, so let's check the answer. Okay, step one, hypothesis. Okay, as I said, Hashna will be always the data follow the given distribution. Okay, so you can write the failure of the getting O blood sample fit to the binomial distribution, or you can just write the question here. Okay, you can just write this data fit to the binomial distribution, also accepted. Okay, also accepted. Okay, so H1 will be opposite to that. This data do not fit to binomial distribution. Okay, so just a simple here. You can write the data. And here the data do not fit. Okay, so you just follow your question. Okay, so then calculate your expected frequency. So the second step is actually chi-square, but to calculate the chi-square, we need the expected frequency. Okay, so this first table given in question, the probability. No need to worry about the probability. Before this, I think most of students, they are worried if this question in final because of the probability. But now, nothing to worry. No? Okay, you already have the probability, you just proceed to the expected frequency. So I expect that everybody can answer this kind of question if it is in final letter. Okay. So the E similar as the categorical data, it is NPI. So PI already given, so you just multiply with your N. So in this case, we have 30 as our N, 30 days here. Or you can calculate the summation of O lah, okay? So you have this E, N also PI. So you will have this E. Okay, so after that, what we need to do? Is there any E less than 5?
Yes.
Which one?
E1, E2, E3.
E1 and
E1, E2.
E1 and E2. Okay, so first we combine E1 with the E2 and then we check again whether they are less than 5 or not. Okay, so we combine first E1 and E2. Okay, but still, okay, your E you still get less than 5. So combine again with the next category. Okay, and then after that, your E greater than 5. So these three combine. So means that we combine three categories here. Okay, so before this, at the beginning, the original data, we have K equal to 1, 2, 3, 4, 5, 5. But now, since we combine these three categories, now K equal to 1, 2, 3. Okay, so the new table, you can construct your new table. Okay, you will have this. Okay, you combine these three categories, then you will have this E. Okay. So the new table with the three categories. Okay, and then after that we proceed with the chi-square test. So how to calculate the chi-square? Similar. Okay, when you combine the category, remember that, okay, the next analysis must be based on the new category. I mean based on the new table that you combine the category. Okay, let's say that you combine the category but your chi-square you calculate based on the old data. Okay, you will get different here. Okay, you will get different. Okay, so if you combine the category again, all the analysis after that must be based on the new data. Okay, the new data means that the data after you combine the category. Okay. Okay, so step 4, you will have this answer for your chi-square. Okay. Step 4 is to find the critical value. So it's T right thetas. Okay. So chi-square alpha k minus m minus 1. Okay. So K here is a new category which is the new number of category which is 3. Okay. The M here just now it is 0. So 3 minus 1 you will get 2 here for your degree of freedom. Okay. So you have this value for the degree of freedom. You can see, right, the answer here.
Yes, madam.
Okay. So make your decision chi-square here greater than critical value, then reject hash null. Okay, so reject hash null means that we accept the hash 1. So you can write your hash 1. Okay, so or you can write here this data do not fit to binomial distribution. Okay, so hash null and hash 1 is up to you how you are going to write, as long as hash null follow that given distribution, hash 1 do not follow. Okay, what word that you want to use is up to you. There's no what we call specific keyword that we use here. Okay, as long as the meaning of your hash null follow the given distribution and hash 1 contrary to that, that will be accepted. Okay, so your conclusion just write back what hypothesis that you support. Okay, any question? Fitting of the distribution?
No, madam.
Okay. Okay, so we go to the contingency table. Okay, so contingency table, it is about two categorical data. Okay, so how we arrange that data, it will be row category and also column category. That's why we call it as a contingency table lah, because we have row variable and also column variable. Okay. So there are two hypotheses involved here. You have the independent task and also you have the homogeneity task. Okay, but the independent, it is between the two variable lah. We try to determine whether the row variable related or not to the column variable, or the row variable affected or not the column variable. Okay, but for the proportion of the homogeneity, we test the homogeneity or equality or similarity of the single categorical data. So means that, okay, for the proportion of the homogeneity, it will be either we test the equality of the column variable, or it will be either we test the equality of the row variable. So either one, okay, either one. It is not both. Okay. So this is how your contingency table. Okay, if you still remember, when we discussed the two-way ANOVA, I said that two-way ANOVA, it is quite similar to the contingency table. Okay, but the difference is the data, the number of data Okay, the number of data between row and column variable. So in your cell here, okay, the number of data between row and column variable. Okay. Hmm. Okay. Okay. So if the two-way ANOVA, the number of the data, okay, the number of the data between, kejap 5 minutes. Okay. Okay, so the difference between contingency table, the obvious difference, the obvious difference it is on the data itself lah. Okay, contingency table we have single number or single data that represent the combination of row and column. Okay, but two-way ANOVA, okay, we have more than two data lah. We have at least two data represent the combination row and column. But the what we call the significant difference is on the variable itself lah. Okay, two-way ANOVA it is a quantitative variable, but contingency table it is about the qualitative variable. Okay, but the obvious difference it is on your data itself. Okay. Okay, this one you can read by your own. Okay. So for this contingency table, doesn't matter what hypothesis that you have, independent or contingency or what we call homogeneity. Okay, the procedure is similar. Okay, the difference is on your first step and the last step lah, the hypothesis and also conclusion, because conclusion follow your hypothesis. But step 2, 3, 4, they are similar to each other. Okay, starting from you find the E, you calculate the chi-square and how you make your decision. Okay, so it doesn't matter which hypothesis that you have, you need to make sure that you know how to do for the step 2, 3 and 4. Okay, because some students, they cannot distinguish whether this question, the question given, it is about independent task or it is about the homogeneity proportion. Okay, so to cater that, okay, you just make sure that you know how to do step 2, 3 and 4 lah, because most of the mark on the step 2, 3 and 4. Okay, if you cannot distinguish what hypothesis that you have, you might lose only 2 marks lah. Okay, for the 1 mark for the hypothesis and another 1 mark for the conclusion. Okay, so just make sure that you know how to do step 2, 3 and 4. Okay, that's how I always told my student lah. Okay, so the chi-square, how we calculate similar, okay, as a goodness of fit task, it is between observed frequency and also the expected frequency. Okay, so the data given is your observed frequency and we need to calculate the expected frequency. Okay, so expected frequency here, it is not based on the probability. It is based on the total data. Okay, so it is about the, okay, the E here, it is about the total row multiplied with the total column. Okay, it is about total data. So you have basically in general, the idea is we have total row multiplied with the total column and then divide by total data lah. Okay, this is the basic idea lah. Okay, the basic idea. Okay, so the formula is by formula. So you have, okay, the total of row here denoted by ni dot. Okay, total of column here, total column denoted by n dot j. Okay, so the total number of data we have n double dot. Okay, so your expected frequency, as I mentioned, the idea is about total row multiply with the total column and then divide by total data. Okay, so let's say that you have this data. So you have 011. So O11 means that the data here is a combination of the first row and first column. Okay, first level of row variable and first level of the column variable. Okay, so in this case, the number of row denoted by small r. So small r equal to 2 lah, in this example, 1 and 2. Okay, and the number of column or the level of the column variable denoted by C, small c. Okay, so in this case, C equal to 2 also, 1 and 2. Okay, so because here we have O11, then means that we need E11. Okay, you have O12, so E12. O121, so we need E21. And then we have O22, then we need E22. Okay, so it must be related to your observed frequency lah. Okay, so E11 means that total row for the E11, it is based on the location of your E. Okay, so E11 is somewhere here. It is here lah, in this cell. So it is about N1 dot with the N dot 1 divided by N double dot. So it is about location of your data lah. So similar, E12 is here. So means that we need E1 dot with the N dot 2 multiplied with N double dot. Sorry, N1 dot multiplied with N dot 2 and multiply with, divide by N double dot. So dah. Okay, until the N. Okay, so that's how we calculate for the E. Okay, so the difference with the goodness of it, your E here, there is no assumption for the E. So the E here, it can be less than 5. So no need to combine your category in this case. Okay, it can be, or it is possible to have E less than 5. So it is okay to have E here less than 5. Okay, no need to combine the category. Okay, because there is no assumption about the E lah for the contingency table. Okay. Okay, so if you have independent tasks, so independent task means that we need to determine whether column variable and row variable related or not to each other. Okay, so it will be some keyword that we use lah. Okay, sometimes we use word independent, sometimes not related or no relationship. Okay, so Hashna always be independent, always be not related, or there always be no relationship. So Hashna means that row and column does not related to each other. Always like that, your Hashna. Hash1, opposite to that. So Hash1 always be row and column related to each other, or exist relationship between those two variables, or dependent to each other. Or another term that we use here, another term that you can use for Hashna, not affected. And here opposite to that, affected lah. Okay, or to be safe, you just follow the keyword in your question lah, and it will be easy for me to mark later. Okay, so you just follow the keyword used in your question. Okay. Okay, so the procedure, okay, state the hypothesis, calculate the chi-square, but before that, we need to calculate the EIJ, okay, and then critical value. So we still have the right theta, but the degree of freedom different from what we have in goodness of fit lah. Okay, so degree of freedom, it is about R minus 1 and C minus 1. So the number of row minus 1 multiply with the number of column minus 1. Okay, and then we make our decision based on right theta. After that, conclusion. So the conclusion here similar as what we do for the goodness of fit test. You just write back which hypothesis that you support. Okay. Okay. We go to the exercise after this. Okay, homogeneity proportion. Okay, so the homogeneity, it is about homogeneity or similarity of the two or more subgroup of the population proportion in the single categorical variable. So task of the homogeneity proportion, okay, we need to task the similarity or the equality of the row variable or similarity or equality of the column variable. Okay, so it will be either one, not both. Okay, so the hypothesis that you need to write, okay, I suggest to you to use the second hypothesis here. Okay, the second hypothesis here. But if you want to use the first hypothesis, also okay lah. But to avoid any mistake happen, it is best to use the second hypothesis here. Why? Okay, sometimes the student cannot distinguish, okay, whether we try to determine the equality of the column variable or we try to determine the equality of the row variable. Okay, so to be safe, we just write H0, all proportion are the same. H1, at least one proportion is different from others. So you no need to know. Okay, we are testing for the equality of the row or we are testing the equality of the column. Okay, the rest of the analysis, it is similar. Okay, so to be safe, you just write the second hypothesis here. But it is not impossible. You also can use the first hypothesis here lah. Okay, but for the first hypothesis here, you need to know, okay, which variable that we need to task, whether row or column, because we need to know how many level that we have. Okay, for the pi here, so how many pi? Let's say that your task for the row, so let's say that small r equal to 3. So it will be pi 1 equal to pi 2 equal to the pi 3. Okay. Let's say that you task for the column. Let's say the column that we have 2. So it will be pi 1 equal to the pi 2 lah, like that. Okay. So the number of pi here depends on the number of level for row or column. Okay. So but again, to avoid any mistake, you just write your hypothesis. You just use the second method here for your hypothesis. Okay. Any questions so far? Okay. Like this question, exercise 6.2.2, the number 1 here. Okay, so test the hypothesis that the proportion of the eye color from different type of the races, okay, are the same. Okay, okay. Some students, they rate type of races as the subject. Means that they test the equality of the race. Okay, but here is actually saya baca balik. Proportion of the eye color from different type of race. Betul lah. Type of race as your subject. Okay, so means that we test the equality of race. Okay, but some student, they rate eye color as your subject. So means that they test the equality of the eye color, which is wrong lah. Okay, so to avoid any mistake, you just write all proportion are the same and H1, at least one proportion is different. Okay, because like this exercise, if you means that, let's say that you read eye color here as your subject, then it will be pi 1 and pi 2 only. Okay, but if you read here as your subject, then it will be pi 1 equal to the pi 2 equal to the pi 3. Okay, so it is different lah. Okay, any question that you want to ask? Last chance to talk with me. No? Okay. Okay, we go to the exercise. Okay, let's see the exercise 6.2.1. Okay. Okay, so we go to the exercise 6.2. I lost connection just now. Okay, so the keyword here, you can hear me, right? Can you hear me?
Yes, madam.
Yes, better.
Okay, so the keyword here is independent. So this is the obvious keyword lah. Independent means independent task. Okay, sometimes you have keyword not related. Okay, sometimes test the relationship between row and column. Sometimes you have word not affected. Okay, so depends on the question. Okay, the keyword used that lead to the relationship between row and column, that's the independent task. Okay, if you have homogeneity proportion, it will be keyword like similar, same, homogeneous to each other, for example. Okay, so you have to know the keyword lah for the contingency table here. Okay, but as I said, the difference between these two hypotheses, it is on your step 1 and also the last step. Okay, so hypothesis and also conclusion. Okay, please make sure that you know what to do for the step 2, 3, and 4. So master yourself on the step 2, 3, and 4. Okay, so let's say that you misinterpret that question, so you just lose only 2 marks lah for the hypothesis and also conclusion. Okay, so step 1, okay, hypothesis. So Hashna always be no relationship between X and Y. Sorry, X and Y, block row and column. So here you can use the keyword given in your question. So independent and hash one row and column related to each other. So opposite to the independent is a dependent. Okay. So okay, so we can construct this table because sometimes I think most of the time we have mark for this table for the total row for the total apa kita panggil, for the total number here. Okay, total row and total column. Okay, make sure that you show somewhere in your answer lah. Okay, and then after you have this table, okay, find your E. Okay, find your E. So I will be grateful if you present your answer in this form. Okay, you have this table, you construct the table, you construct this table for your answer. Okay, the first column you have the observed frequency, okay, given frequency in your question, and then you have the E column, EIJ, the expected column, and the third column is actually the chi-square lah because here we don't need to check whether the E less than 5 or not. So after you have the E, then proceed to the X square. Okay, proceed to the chi-square. Okay, no need to check for the E. Okay, so the third column is actually the formula that we use to get the chi-square. So the summation of the third column, you will get your chi-square task. Okay, so again, I will be grateful if you present your answer in this form because it will be easy for me to check your answer and also it will be easy for me to mark your answer. Okay, of course, this kind of question will be in final later. Okay, because if you go through the final exam question, it will be 2 questions from chapter 6. Okay, the first question, goodness of fate task, and the second question is a contingency table. Cuma kita tak tahu yang mana satu je keluar. I mean independent or homogeneity. So similar to the goodness of fit lah. Okay. It might be categorical data or fitting of the distribution. But nothing crucial now about the goodness of fit task. Okay. Because even though you have the fitting of the distribution, it is easy because probability already given. So it doesn't matter which question will be in final. So but you just prepare yourself for the step 2, 3 and 4 lah. Okay, that's it. Okay, so we already discussed how to get the E just now by using the simple example. Okay, you should get your chi-square, this one. Okay, so summation of your third column here, that's your chi-square. Okay, second column, your expected frequency. So we already discussed just now how to get the E. Okay, so please use 4 decimal places. Do not round up the value. Do not round up to the discrete number. Okay, just use as it is. Okay, even though it is a frequency, okay, do not round up to the discrete number. Okay, just use as it is 4 decimal places. Okay. So you get your chi-square test, step 3, critical value. Okay, as I said that we have right theta, chi-square alpha, okay, degree of freedom R minus 1, C minus 1. Okay, so in this exercise, your R equal to 2, your C equal to 3. Okay, R number of row, C number of column 1, 2, 3. 1, 2. Okay, so then you get your critical value. Okay, so chi-square here, step 4 decision. Okay, chi-square greater than critical value, then reject rational. Okay, because decision is based on right theta. Okay, step 5 conclusion. Okay, as I said, no need to bother yourself to write sufficient evidence or insufficient evidence. You just write which hypothesis that you support as it is. Okay, with the alpha lah. Any question? Okay, so this subtopic, it is just a simple. It is a simple calculation, but it is a lot calculation lah. Okay, there is a lot calculation involved, but it is a simple calculation. Okay, for the 6.2.2, the homogeneity proportion, I think it is yours. Okay, because basically you just repeat similar step as an independent task. The difference is on your hypothesis. Okay, step 2, 3, 4, they are similar to each other. Okay, you just do your exercise. If anything, just let me know. Any question? So that's it, the chapter 6. Okay, the subtopic 6.3, it is about Microsoft Excel. Okay, you can go through by your own just to see how we calculate the chi-square using the Microsoft Excel. Okay, so far in final it will be manual calculation lah. There is no Microsoft Excel because the output for the chapter 6 it is not similar as a chapter 5 and 4 lah. Okay, it is different. We have to key in the formula to get the chi-square. So it is different from chapter 5 and 4. Okay, that's why we go to the manual calculation lah for this chapter. Okay, So with that, we finish the chapter 6. With that, we finish the applied statistic course lah. Okay, I mean all the syllabus for the applied statistic course. Any questions so far? No? Okay. Okay, so I believe that you already know the date of our final. Saya pun lupa dah. When? 26 or 27 or 25th? 25th, okay, 25th. Okay, so 25th is the final exam for this course. Okay, so it will be the online final exam. Okay, the online test or the online final. Okay, so the detail of the procedure will be shared later lah. Okay, I will share later. Okay, the detail of the final exam. I mean the method or the procedure for the final exam. Okay, I will share later. Okay. So now I'm work hard on marking all the assessment. Please be patient with me. Okay, inshallah I will finish everything by next week lah. So inshallah the end of the next week you will get all the marks lah. Okay. So sorry for the delay lah. Okay, of your assessment mark. Okay. So preparation for the final. I don't remember how many questions that we have, but I do know that most of the mark, as I mentioned before this, most of the mark are coming from chapter 4, 5 and 6. Okay, most of the mark. You will have about, I think, 2 questions from chapter 2 and 3, 2 questions from chapter 4, 2 questions from chapter 5, 2 questions from chapter 6. Okay. Okay, the distribution like that. Okay, chapter 1, it will be everywhere because it is a theory about the applied statistic. Okay, but there is no more manual calculation like box plot lah. Okay, in the final. Okay, but most of the mark coming from chapter 4, 5 and 6. So as I mentioned last week, okay, if you want to score final, make sure that you focus more on the chapter 4, 5 and 6. Okay, make sure that when you do your final exam, okay, I can see that from my experience, most of students, they go to the question from chapter 4, 5 and 6 first, and then they go back to the question with chapter 2 and 3. Most of the students like that, but it's up to you. You can plan. Okay, you can have your own strategy lah for the final exam. Okay, so to have that kind of the strategy, that's why it is important to try the final exam questions from previous semester. Okay, so you need to try at least 3 to 4 set of the final exam so that you can get the pattern. Okay, you can know the pattern of our final exam. Okay. The pattern will be similar. I mean, how we arrange the question will be similar as the previous final. Okay, the difference is the question itself lah. Okay, but the pattern will be similar. We start with the chapter 2 first, 3, and then we go to the chapter 4, and then we go to the chapter 5, and then we go to the chapter 6. Okay. I can sure that chapter 5, it will be question for the simple linear, it will be question for the multiple linear. Okay, for the chapter 6, as I mentioned just now, it will be 2 questions from chapter 6. Okay, for sure, the goodness of fit, 1 question and another question from contingency table. Okay, but I think the easiest one is a chapter 6. Okay, because so before this, student are afraid with the fitting of the distribution, as I mentioned, because of the probability. But now probability already given in your question, so there's nothing to worry about the chapter 6. Okay, just a simple calculation, but you have to be careful on the assumption, for example, goodness of fit. Okay, and also contingency table. The easiest one is a contingency table. Okay, I hope that all of you can score that part. Okay, because the hypothesis for the contingency table, we have similar step, the difference on your hypothesis. So I expect that if you lose your mark, it will be only 2 marks on the hypothesis, and also conclusion. Okay, but still you have to know the theory of the contingency table lah. Okay, the data itself, okay, the assumption of your data. So the data must be qualitative, for example. Okay, it must be at least 2 categorical data, for example, for the contingency table. Okay. What else that you have to know? And also, the reason why you have to try the final exam is first you need to have your own strategy line, which one to answer first, okay, and also to train yourself lah to solve within 3 hours, okay, to solve within 3 hours, okay. I will confirm later whether it is an open book or not, but even though it is an open book, okay, as I said, similar as a task before this, and take a lesson from the task, okay, even though it is an open book, but still you need to prepare yourself, okay. If you don't prepare, you don't even know which part that you have to refer in your module, in your notes, okay. So it is important to prepare yourself, especially final, we have a lot of questions and it is about the whole, the whole course, okay. So it is important to prepare yourself. So make sure that you do the exercise tutorial and also the final exam question. What else that you have to do? Okay, I think that's it for the final exam. So after this, maybe next week I will share the procedure lah for the final exam. Final exam. Okay, so during the preparation of the final exam, if you have any question, you are welcome to text me lah if you have any question. Okay, if you are in UMP, if you want to see me, okay, you can text me and then we can set up the appointment lah, okay, if you are in UMP, but with the SOP lah, as you know, okay. So if you want to see me in my office, then you just make appointment lah, okay, and then we can discuss. Okay, if not, you can just text me as usual lah, okay. I think that's all for today. So before we end this class, I would like to apologize for any wrongdoing, okay, for any mistake that I made throughout this semester lah, okay. So again, be patient with the assessment mark. I'm working very hard on that, okay, to finish everything by next week, okay. But anything you can just let me know lah, okay, you can text me. Any question? Last chance to talk with me. No? Okay. So till the end kita tak jumpa each other. So saya pun tak kenal you all unless I know the name lah. Okay, so make sure that I don't see same name next semester. Okay. InsyaAllah we see each other later. But I don't want to see you in this course again. So please make sure that you do well in your final and score well in your final and then pass this course. Okay. Anything you can text me. So that's all for this course, I think. Okay. So thank you, class.
Thank you, madam.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Okay.
madam.
Okay.
Thank you, Madam.
Okay.